Hello, everybody, and welcome to Python 101. This is session number 6, and today we're going to talk about looping in Python. So let's get started. In the end of the session, I'm also going to talk about some class logistics, like the assignments, submissions, and all those things. Let's get started. The first thing that we're going to talk about is iterators, iterators and iterables. So what is an iterable type? In Python, we are talking about sequences, right? The ordered collection of items. Any ordered collection of items that we have discussed so far, and also we're going to discuss in the next few weeks, they are all also what is referred to as iterables. What does that term mean? This means that Python knows how to iterate on these. That is, whatever their structure is, it's from left to right, however you want to call it, or top top to down. Python knows how to go item by item in these sequences. You can call them collections, containers, whatever you want to call them. Okay. So I'm going to show you the most rudimentary form, what an iterator is, and then we're going to see some iterators in like iterator objects, and then we're going to write some code to loop through those iterators. So I'm going to start with the most basic things that you can do is when you write iter is a built-in function. You can call the iter function on any type of iterable. There is a sequence on which Python knows how to iterate to create an iterator object. So suppose I have a string. String is a sequence of characters, a collection of characters, an ordered collection of characters. So it has a left to right order. So if I call an iterator function on S, it will return a string iterator object. Just give me a second. It will return a string iterator object. You can assign this to something. You can say it equals to that. Now, when you do next of it, it gives you the next item that this iterator is pointing to. If you do this, if you keep on doing this, you will reach end, and in the end, you're going to throw in error, right? So essentially, you reach and you get stop iteration. Let's go to a quick example of writing two iterators at the same time. So suppose you have a string called, similarly again, Saturn. You pass it through the iter function and you get an iterator. Suppose that is it. So essentially, the it is pointing to the very first character. So it knows where it is pointing right now. When you write next of it, you essentially go to the next one. Now you can have multiple iterators on a sequence. You can have another it1 here, which is pointing to the first, while the other one is on, let's say, t. So how you can do that is, let's just do this whole statement again and let's write it1 and it2. You do next of it1 and it1. So now this it1 is on t right now. If you do next on it2, you will notice that it's still on s. So you can have these multiple iterators on the same structure, right? So that's how it works. You have a built-in. Now all these structures that we have encountered so far, or we'll encounter in the built-ins, are all iterables. So let's take a list of, let's say, numbers. you can call an iter on that, and that also returns a iterator object. You do next of it, and as we move along, we'll see more things. Right? I'm going to give you 30 seconds if you want to try this.
You
All right,
have
so
next. Sorry,
go
can
ahead.
I ask a question? Okay, you
Yeah.
have next. Do you also have something like previous?
We'll have to check. Is there a previous? There might be. No, no, there is. I'll have to check. I don't know if you can go back, but I'll have to check. Okay. I've never used a previous, I mean, in which we have gone one behind, but you have a reversed iterator that works in that way. So let me talk about it in a second. So the iterator object that we have does not contain anything. So suppose you have a string here, Saturn, or you have a list. When you create an iterator object, it is just an object which knows how to go on this structure and what is to be pointed to in the next one. Okay, it at no point of time it contains the entire thing in the memory at a time. Okay, it only points to the one thing that you're pointing to right now, either this or either this. So if you think that you create an iter, if you call this and then you, let's say you get an it object and you can just print it and that print will give you the whole string, that will not happen, because this is just an iterator object which knows how to go from left to right on this or top down on this. Okay, so keep that in mind. Let's talk about a couple of iterators, and we're also going to talk about how to go in reverse. So there are two things I want to talk about. So first is, and suppose you have a string s equals to Saturn. In one of the class I talked about sorted, right? How it returned a list. You write sorted of s, it returns a list of things sorted. If you talk, there's a built-in called reversed. If you call reversed on s, it returns a reversed object at whatever this location. This is a memory. So it returns a reversed object. It doesn't return the object in reverse. Okay, and this reversed thing is an iterator actually. So if you say it equals to this, and you say next of it, then you will notice that the last thing will be printed. Then the first, then this third last, fourth last, first character, and you end. So this reversed is an example of an iterator object. Another one, after that, I'm going to give you some time to try these things. Another one is an important thing called range. Okay, there is a range class. If you give it any number, let's say you give it 100, then it generates a range object. A range object starting with 0 and going to 100. Okay. Once again, it is not storing anything from 0 to 100 at any point of time. It is just saying that this is a range object which starts at 0 and goes to 100, and it knows where it is right now. So if I do, let's say, x equals to range, and I do next of x, sorry, my mistake. I take it back. So the range is not an iterator. Range is different. I'll talk about this in a second. So this range object that you have here, on this structure, you can go from left to right. You can generate a range of numbers going from 0 to 99 by doing a loop, or you can cast it using something. Like for example, if you say something like, let's say, a list, that generates a list of numbers that start at 0 and go all the way to 100 minus 1. Okay, just give me a second. Let me mute everybody. Right. So the range object is what we use when we need to generate a sequence of numbers anytime we want to do that. And why is it useful? It might be useful in certain situations. Suppose you want to look into like you want to generate the list of first n numbers or first n even numbers, first n odd numbers. Then this is the structure you can create to loop over. Okay. The range not only does that, you can also specify a starting point and an end point. If you do that, then essentially you have a range object which is starts at 1 and ends at 4. So 5 is not included, it ends at 4. So if you do, let's say, a list of range of 1 to 5, get 1, 2, 3, 4. So you can loop over this thing as well. And I'm going to come to the looping right now. Okay. So, but before I come to looping, let's take 30 seconds. You guys want to try it out yourself. And then I'm going to talk about looping. So let's extend the range object a little bit more. Okay. So I talked about, you can have an initial and you can have a final, right? You can say 1, 200. You can, if I just cast it into a list right now, then you get a list like this. You can also, in the range object, express the steps. So you can also add a third argument saying that go from 1 to 100 in the steps of, let's say, 2. So now the range object will create this type of an output. Once again, range is just an object, but we are casting it into a list, and Python knows then how to construct a list out of it. So essentially, it's creating this whole list. But the answer is 1, 3, 5, 7. You can see it's incrementing in these steps of 2. So I can, for example, generate all the odd numbers like this with this syntax. Let me start Tony.
Do you have to define the range, or can you just, the way you have it, list range 1, 100, 2?
What? So when if you define a range like this, you get a range object back.
Right.
On this you can do a whole bunch of things. You can do a looping on it, or you can cast it into a list, and then you can get these numbers. But I'm going to show now the looping way.
Okay.
Okay. So I'm going to start in the discussion on looping now. So with the range, with us, we can discuss some looping. Okay, the first thing that we're going to talk about is a for loop. I'm just going to save this. So a for loop is basically a loop which iterates over a container of some sort, okay, or an iterable type. So suppose I have a string, okay, let's just call it name equals to, let's say, Frodo. Now, if I want to go through each character and do something with it, then I can use what is called a for loop. For loop automatically knows how to go in a sequence from left to right, okay, and internally it uses that iterator object. So let's begin. So the syntax for loop is you cite for and you name some variable, whatever variable name you want to call. You can say for, let's say, character in name. For each character in name, essentially you read this like this, and you say print the character, suppose, and you run this, and you get this. So automatically for loop is going through each item here and it is printing that character. And by default, the print is introducing a new line. Hence you're getting each character on a new line. You can change the behavior by, let's say, adding a space, and then in this other example, you'll get the for loop working like this. So that's the simplest syntax for looping. You write for an item in some container or collection. You basically do something with item. If let's switch this. If I say for character in reversed of name, okay, and then just use the similar thing here. If you do that, then you get the Frodo in reverse, right? Because now you have set up a reversed iterator on that. Once you set up a reverse iterator, you're gonna iterate from the back side to the front side. Okay, I'm gonna give you 1 minute if you want to try this, and you can ask me any questions as well. Let's take this example a little bit more further. Let's create a new line. This same thing you can also do within range object. I'm saying for number in range of, let's say, 10, print number. Remember, this is just one line statement, so I don't have to go to a new line. I can just write on the same line, print number like that. When you print it, once again, you get 0 to 9. And I'm just similarly going to introduce n equals to this. So you get something like this.
So the indentation is not really mandatory?
I mean, it's mandatory if you remember the last lecture, it's only mandatory if you have multiple statements. If you have something else as well, then
Okay.
if it's just one liner, you can continue it on the same line. All right, so that's the range example. Let's expand this a bit further. Suppose I want to start with 5. Then this will go from 5 to 9. All right, and let's suppose I want to do this from, let's say, 1 to 100 in the increments of 2. Then I can do this, and you will get all the odd numbers here to here. Or let's say you want to do reverse, then you can also do reverse. You can say go from 100 to 1 in the decrements of, let's say, 2, minus 2. Let me try. Minus 2 should be the then you will get a reverse. 100 starts with 100, and then it's going to go all the way to 1. It will not go to 1, it will go to the 1 less than 1, but yeah, essentially, and then in the decrement of minus 2. All right, so let's take a quick example. Okay, suppose you have a string. Okay, so I'm just going to say this example is something called, let's say, print. Okay, find even .py. Suppose you have a string s equals to, let's say, my name, Himanshu, and you have to print all the indexes, or you have to print all the characters in the string which are even characters. Okay, so even numbers. So in that case, how would you go about it? Suppose this is the string which has these indexes. I only want to print the characters on the indexes that are even. Okay, let's take 0 as even. Okay, let's forget about it. Let's take 1. Start with 1. Everything that is on even index. Let's say we want to print that. How do we do that? So the first thing that we can do is we can iterate over these numbers, then find the index which are even, and then print the corresponding characters. Okay, so I'm just showing you a quick example on like looping real quick. So suppose you have a string. These are the indexes. So what you can do is somehow you can get a range object that's from 0 to 5, and then you can go start with 1 because you don't want to include 0, but you can find anything that's even. For example, this is an even. Then when you find these numbers in your, when you're iterating over that range object, you can just print the corresponding character by writing, let's say, s of whatever x, where x is the iterator object. So what you can do is you can generate a range object by saying len. Okay, so what is the len here? L equals to len of s. Then the range of L will give you all the numbers from 0 to 8, right? 0 to 7. Well, just give me a second. Oh my God. 0, 1, 2, 6, 7. Yeah, the length is going to be 8. So this will give you a range object from 0 to 8, which is 0, 1, 2, 3, 4, 5, 6, and 7. So if I say for x in range, and I say print x, then this will print all the indexes right now. But if I say s of x, then I can print all the characters on those indexes. This is the roundabout way of doing the same thing that we saw in this example. For example, here we just said for character in name, print the character. Now we are saying for a number in the range, print on that index. Now we can write the logic here as well. We can say if this x is even, say if x modulo 2 equals 0, then you print. And once again, the 0 will be printed for now, but we can eliminate it by increasing our range from 1 to L. So you see all the numbers, all the characters at the even index are being printed now. So sometimes you have to go, when you iterate over a string, the usual way of iterating over a string is something like you can say for x in s print x. That's the usual way of doing things. But at times you have to go through the indexes because you want to do something with the indexes as well. So in that case, you use this approach. Any questions? All right, let's talk about another form of loop. This is called a while loop. Okay, and I'm going to create a new. While loop is another form of looping, which is different from for loop. Right? In a for loop iterates over a container or over a collection, you can say. For loop iterates over some kind of a sequence, collection, container, whatever you want to call it. While loop iterates over a Boolean condition. So while loop will iterate for a Boolean condition till that Boolean condition is true. When the Boolean condition is false, while loop will stop. So the syntax for while loop is you say while some condition. like how you write if, and then do something in the loop. So this loop will keep executing till this condition is false. Okay, and this false condition for while loop is not just the Boolean false, but an empty structure as well. I'm going to show you this as an example now. So suppose that you have x equals to 5 and y equals to 10. Suppose you write while x is less than 5, x is less than y, let's say print something like, let's say x is less than whatever. Let me write a simple format, and then this value of x, comma, y. So we're just writing x is less than y. We're just printing that. This loop will keep executing till x is less than 5. Hence, this loop will keep executing forever because x will always be less than 5. X is 5 and x will always be less than y because x is 5 and y is 10. But if you increase x by 1 here, let's say, then let's see what happens here. When you run this, you will say x, which is 5, is less than y, which is 10. Then x, you say x plus equals to 1, so x is incremented by 1. Then you say x, which is 6, is less than 10. And this loop executes 5 times till x becomes 10, and this condition becomes false. So that's the key difference between a for loop and a while loop. Of a while loop will run on some kind of a condition. And when you write a while loop, so that's the difference between for loop and while loop. Let me just keep a few things here. You have a for loop and a while loop. So this goes over a collection. This goes over a condition. Iterates over a condition, right? So this automatically expires, right? Here you have to provide the code logic to expire, right? You have to make some change for this to expire. If I don't write this will become an infinite loop. So there is a possibility that you will run into infinite loops in while loop more, because people do forget sometimes to increment or make it or go to a condition that will invalidate the loop. So that's a while loop. Since while loop iterates over a condition, you can write something like while true. This is an infinite loop. When you write while true, that means you're running a loop that you don't want to end. You can, for example, write something like this. Suppose I say input. We encountered the input function in the first class. I'm going to say enter a character. And suppose you just x equals to this. If you just run this code right now, enter a character. You put q, enter a character. This will keep on running because there is a while true. It's not going to stop ever. So I'll have to manually kill this code. Just give me a second. So essentially, this is a while loop, which if it's a true loop, it will never break. Yes, question.
I mean, it's not related to while, but how do you stop manually, your terminal? What is the command for that?
Control C.
Control C. Okay. It's the same. Gotcha. Thank you.
Yeah. I'm not sure about the Jupyter notebook, but yeah, this is Control C. So essentially, yeah, if you run into a while loop which is infinite, you have to manually kill it. Now, let me show you few things to enter an exit loop. If you introduce certain keywords in the loop, then the loop automatically, then there are a few things that you can do. The first keyword is break. If your Python code gets to this break statement, then it will break the loop and it will come out of the loop. Okay, let's see an example. Suppose in this while loop, which is while true, I'm going to say enter a character. Then I'm going to say if the character, let's say, equals z, then just break. And you can say print here out of loop. So this while loop, which is always true, you can break it if you enter the character as z. So let's run this code. We come here, enter a character. So I A, B, so it's gonna keep working till you keep entering the characters, and then you enter Z. At that point, your loop breaks. So break is one of the keyword to break the loops. And this keyword is same in all the programming languages, and you must have seen it in your past, but yeah. You can do that. The another keyword is continue. Continue, this basically breaks the loop. And continue goes to the top of the loop. So if let's say you have some loop condition, okay, suppose that you have x equals to z, then break. Let's just enter a statement here called print, and you can say character entered, or you can just say something like this. You can say whatever the character is being entered is basically x multiplied by 10. So when you run this loop, listen what will happen. You are at a, so you see all the characters being multiplied by 10 until you hit z. Now you can add another condition. You can say if x equals to let's say g, then continue. If you do that, then essentially when you run this, f, now you hit g, and notice that print statement did not execute. This print statement did not execute. As soon as you hit the continue, you go to the top of the loop again. So that's what you did. You went to the top of the loop. And you continued further. Any questions? You could have defined the condition outside. Let me complete that. And so you could have said, let's just take a new class, okay, and just say,
it is more efficient. I mean, because like for example, you're going to resolve something, you're going to look for something that has a solution 100%,
exactly.
and you're going to let it running by true, and then define your condition inside. So this condition you can get it outside, or if you ask the people to enter what is your, for example, the condition.
Yeah, exactly.
So
you can do something like this. So you can say there's a flag which is true, and then you're saying while flag, and let's just continue with this logic. And if x equals z, then you just set the flag as false.
Okay. Oh, okay. Oh.
Now the very next iteration, when you go to flag, it was going to fail. So if you run this, you say a, this is okay, and then you run z, the loop ends. But yeah, this is the way you should be doing it. I was just showing an example of an infinite
Example.
loop.
Okay. Thank you.
Yes. Yeah. Any other question? There was a question.
Yes. If you